Let's say we have a box and it is placed on a scale that can read its weight. And inside the box, there is a balloon tied to a stone. So the balloon is not going to touch the ceiling. It is held by the stone and the whole system is closed. Now, what will happen if I cut the string of the balloon so that the balloon right now is floating? Will that make the scale read a smaller number because right now the balloon is pushing up against the ceiling of the box? The answer is that the weight here should equal to the weight here. Cutting the string will not make the box lighter. The reason is that when the balloon is touching the ceiling, giving it a force going up, the rock has a other force that is going down, which is m rock g. Let's just call it mg. And when the rock is tied on when the balloon is tied with the rock, the mass here, the weight that the rock gives to the floor of the block will be smaller because the balloon is now pulling on top with the force m1. Therefore, when we haven't cut the string, the weight here will be smaller than mg. In fact, m1 minus mg will equals to the weight. So therefore, at here, the balloon is pushing the top of the box, but the weight of the rock, entire weight of the rock is pushing down on the floor of the scale. So the weight will not have a difference no matter you cut the string or not. Now, let's analyze this situation with the formula that we use. We know that for a system, the sum of external force will equal to its total mass times the center of mass acceleration. So in the first scenario, because the balloon is tied, the box is not moving, the rock is not moving, nothing is moving. So the center of mass acceleration is 0 here. Same with this case. Even though the balloon is on top, but at the end the balloon will stop floating, the rock will stop moving. So everything here is having, so the system over here is also having a 0 center of mass acceleration. So what it means that the sum of external force, which is just the normal force on the scale that the scale gives to the box, which will also be the weight, which will also be the reading here, and the gravity. We have the gravity acting on the balloon. Let's use the blue arrow as gravity, acting on the box and acting on the rock. So no matter the balloon is on top of the ceiling or tied to the rock, the gravity works on it is going to be the same. Same with other objects. In both scenarios, gravity is not going to change. So if they all sum up to 0, which means that n1 or n minus gravity equals 0, then in this case, n minus gravity, which is also 0, tells us that if the gravity is the same in both cases, then the reading on each weight, each scale should also be the same. So we see the internal force between the balloon, the box, and the rock will cancel each other. So when we analyze the external force, which is gravity, and the normal force provided by the scale, they will not be affected by the internal situation of the box. So in this case, both boxes will have the same reading.